welcome to Mighty Finsights. My name is Rory Holland, and I'm joined by Zain Premji. And Zain, so good to have you here.
Thank you.
The name of your company?
Secured Quantum Services.
I got SQS.
Yeah.
I just wanted to hear you say it because you have such a cool accent.
Appreciate it.
Where are you from?
From Manchester, England.
And how long have you been in the States?
So I moved to the States, I want to say in 2010 or 11. Finished my studies here in the US, went to Texas A&M, got a degree in economics. And then as every graduate, you're kind of job hunting. So I got actually lucky. In my final semester, I actually landed a job offer with Deloitte Consulting in Houston, Texas, of all places. So that's where I started my career.
Wonderful.
Yeah.
Yeah, and you're up to something so interesting. I can't wait to unpack it with you.
Sure.
So maybe for the audience, just a little bit about what you do, the business that you're in, and then I've got a bunch of questions for you.
Sounds good. So let me start by saying SQS, in a nutshell, is on a mission to revolutionize the way we as a digital world communicate and transfer data. And with that, we are re-architecting the way our current internet infrastructure operates, because we hear about it all the time. Encryption's being hacked, cloud data breaches happening all the time, cyber warfare is happening. The Ukrainian war is kind of a stark reminder of how much of the war is fought over cyber. And there is a need for us to create an environment which is quantum safe for the upcoming imminent sort of quantum era, if you will, where standard encryption might be obsolete by as early as 2028, which is crazy to think about when you think about how we operate. SQS is building a global secured communication network using quantum mechanics, and we can unpack that a little bit more, to make sure that we have secured communications, quantum cloud systems that are quantum safe, and is sort of the next phase of where quantum and computing and information technology and digital interactions are going.
Maybe start with quantum technology.
Sure.
That's fascinating, by the way. And when I read about you guys, you've been at it for a while in putting this together.
Yeah, it's a big
I can only imagine what's all involved, but definitely want to get into that. But so
Sure.
What is quantum technology? How is it different than the current technology that you're using?
So quantum as just a field of study, right, is very broad. There's different aspects of quantum. We hear about it in the news all the time. Quantum computing is probably the biggest one that we hear about. Quantum computing is, in its most simplest form, is used to create opportunities to solve very complex problems in nanoseconds. So think of your highest military grade encryption. You put it into a quantum computer and it will break it within nanoseconds. That's essentially the goal. And it could be used for other good deeds as well, right? But that's currently how we're seeing adversarial nations using quantum computing. There is quantum sensing, which is an area of quantum sensors that can detect the very granular type of movements in actual weight. So things for like medical imaging or detecting things underground, quantum sensors would be used for. Then there's quantum timing, which is essentially quantum clocks, which is extremely, extremely accurate. I feel like regular clocks that we know about, lose seconds on a regular basis. They'll either slow down because of battery or daylight savings or whatever it happens. They're accurate to the most part, but quantum clocks are so accurate, they only lose a second every 15 billion years, which is just insane to think about. So when you think about like GPS tracking or financial transactions that need it down to the nanosecond, quantum clocks is actually a great use case. So those are just some examples of the different flavors of quantum, but the way in which we are building our communication network is, if you think about the internet today, and we take a step back, the internet is using broadcast technology, which is radio-based, so it's wave-based. It sends a signal out and it's broadcasted to everyone, kind of like a loudspeaker. Whoever is trying to listen to that could very easily listen to it and intercept the information. If you think about quantum networking, it's point to point. So it's very direct in its target of where the information is coming from and where it's going. And instead of wave-based technology, it uses light. So this is where quantum physics and the sort of magic comes in to it, where if anything tries to intercept that line of sight or that thread of communication, the light will immediately disintegrate. So all the information that it was carrying will just go poof. And that makes it very hard for people to penetrate and hack.
I can only imagine the applications in finance.
Yes.
That is what we want to talk about today.
Right.
But you also mentioned other industries.
Yes.
What are some of those others?
So right now, the biggest spaces that we're playing, if you think about just critical infrastructure as a general term, right? Within there, you have healthcare, a lot of sensitive data that needs to be protected. There is utilities, power and utility companies. There is financial services. And then right now, we're also seeing a lot of traction with space, space communication. How do we reduce power consumption to have secure communication lines between satellites or satellites to Earth? Space is another aspect. And then finally, we're seeing a lot of interest between Department of Defense, national security applications.
I can imagine between Department of Defense, energy, just those two. We talk about our energy grid and everything else. There's so much sensitivity to being hacked. Quantum is something, I confess, when we first talked.
Yeah.
In my mind, quantum is like Back to the Future. So like I've heard of it.
Yeah.
It sounds super interesting. But in reading about you guys, you've been at it for how many years?
So my co-founder, who just had an idea in his brain many, many years ago, he was faced with the question, how do you secure data in the cloud from a client? And he gave a very frank answer and said, you just can't do it. It's not possible. If you truly want to secure this data, it's not possible. So that got his mind going. And he's a gentleman who's, built an own sort of custom ERP system, sold it off to American Airlines many years ago. So he's a genius in terms of the way he thinks of just architectures, and he comes up with ways to figure out how to make something possible. So he came up with the idea, I want to say close to 15, 16 years ago. Before quantum wasn't even in the picture though. It was like, how do you secure cloud using a private network? And we hear about all these companies that have come to play, right? That they've done private networking, they do private on-prem sort of data servers for security aspects. So when I came into the mix about 6 years ago, quantum was sort of up and rising, and we were kind of brainstorming. I was like, Ray, how are we going to penetrate a very saturated market right now, right? These two guys trying to figure out private networking, who's going to listen to us? So we started brainstorming, and as many startups do, you pivot, you bring ideas to the table. And then we said, how do we make quantum possible in a private network landscape? And we were faced with many challenges. There's a distance issue, like quantum can only carry certain information for around 50 to 75 miles before you need like a quantum repeater. So infrastructure would be very expensive. How do you, use quantum technologies in organizations today without ripping up the current infrastructure and the current architecture they have? Again, that could be very costly. So when we were designing the architecture, we were saying we need to design an architecture that can address these problems and makes quantum technologies accessible, affordable, and scalable. So to answer your question in a very long way, we did about 12 years of R&D in total, maybe close to 15, to figure out what those architectures would look like. We officially launched as a company last November because we were like, this works and we can do something about this. We got accepted into our first DoD accelerator a few months before we formed. And now we have pilot customers, we have secured strategic partnerships. So it's been a journey, but I'd say the last 18 months have been very exciting. Our team has grown from 2 to 17 people. So yeah, we've been at it a while, but things like this can take time.
Yeah, for sure. And particularly when you're developing new technology and you're trying to overlay it on existing infrastructure. I want to go back to something you said that your co-founder said, that it can't be secured.
Yeah.
Would it be true then that we count on security, or we assume security, but from what you just said, nothing is really secure in the current way we do it?
In a very unfortunate sort of sense, yes, that's accurate. There are solutions that can safeguard current assets. Like if you think of just financial services, right? The word that comes to me is trust. It's trust with your money from a consumer perspective. It's trust from a financial systems perspective. Who's sending the data? Who's accepting the data? Can it be interceived or intercepted between that path? Things of that nature. And when you think about it along those lines, we're kind of on a time clock. It's only a matter of time before traditional or the highest level encryption is broken. And we're already seeing it, like large organizations have data breaches all the time. And it's unfortunate, right? Especially when like credit agencies get hacked, like the biggest one that we saw a couple of years ago with one of the big credit agencies. They had a huge data breach, exposed millions of data. So it's not to the fault of the organization. Yes, we can always say there could be better governance, better controls in place. Zero trust is something that we base in the architecture level at Secured Quantum Services, but it's the internet. It's 40 years old. That was the last time the internet was sort of invented. And when you think about how quick interactions and transactions are happening with this AI boom, especially in the fintech space, where these transactions are trying to happen at machine speed, the internet infrastructure in itself, there's only so much you can layer on top because in itself is fragmented. So that's where we have been working to re-architect an infrastructure from the ground level up and figure out how we can make this possible.
Where in your mind does AI play in this? Because we think about, when I hear you talk about what the future looks like, and then the ability of someone who wants to do something to hack an organization or hack data.
Yeah.
I hear it all the time about penetration testing and that we're constantly being hit from other countries. And
right.
It seems like a concerted, hesitate to use this word, but it feels like a war, a data war almost, where people are actually attacking us all the time. And if our infrastructure, like you said, is 40 plus years old and it's sensitive to this and it's penetrable, how can we have faith in a system? Use the word trust. I'll use the word faith because a lot of us just have to have faith because we don't understand it. Or the average person doesn't.
Yeah.
How can, from your view, does this new technology replace the existing technology? Like, is it a bridge to the future, do you think?
I mean, that's our goal. So like our moonshot is we are going to build a quantum internet. And the way we get there is, and don't get me wrong, right? Like standard encryption at the highest level is very, very like ridiculously hard to break. You need a lot of compute power. So where quantum computers can also, they're seeing the advanced threat. You need a lot of manpower, you need resources to break current encryption. But the fact that it's just happening on critical items, which is right now national security, that's where we're seeing the biggest threat. It's happening all the time. So back to SQS and what we're trying to do is we're trying to pave the way that there is a new way to do this, and we could be quantum safe for the next foreseeable future if we just think differently on how we build our infrastructure and how we architect it in a way that has security, trust, and regulation and governance baked in at the infrastructure level. Usually security is an afterthought. You don't think of it as an issue unless you've been hit, usually, right? And that's where we are doing it differently and spending the time where it's an essential part of our infrastructure before we build anything on top.
What has been the response in the financial industry to what you guys are doing?
It's been very exciting in a nutshell, because when you think about how many millions, maybe billions of financial transactions happen on a daily basis, whether you're a traditional fintech company or you're in cryptocurrency or you might be in insurance, whatever data is being exchanged and what our cloud providers are providing for their services that they are hosting their technologies on, they are very well aware, especially like the CIOs of those companies. They are very well aware of the encryption standards that they need to consistently maintain all the governance and compliance with GDPR for Europe, the Californian governance rules that they have for fintech organizations. How do we consistently keep this up to date when we are transacting at machine speed? Like, it's just happening so quickly, and money's coming in, which is great for any business, right? But it's like, you're going to find yourself in a position where you'll be caught by maybe one of these attacks, or something happens and there's a leak somewhere, and you'll be scattering to figure out how you play it, or how you react, or how you bolster your security again. So when we've been talking to fintech or financial service organizations, it's been very promising. And, this is where we're taking pilot customers right now, because it's the perfect place to set up, no matter if you're a small organization or a large organization, just a quantum safe environment within your office. Take a couple of use cases, and you can see the drastic difference of the security, the communication, and the compute power it could provide to power a massive industry like financial services.
Yeah, could you describe a use case?
So one of the ones that we are doing right now, and this is not directly with financial services, but it's for an organization called Space ISAC, and they're based in Colorado Springs. And what they are is they're a vulnerability watch and data center where they monitor adversarial threats in space. And they are connected to maybe 100 DoDs and MODs of the world and private companies who are supporting the security of space. And the pilot that we are working with them is the threats that they detect needs to be aggregated in a system, and it needs to be dispersed to the correct DoDs and MODs of the world where the threat might be coming to. And if you think about that level of degree, it needs to happen fast, it needs to happen securely, and it needs to happen at machine speed. So they brought us on to do this pilot project where we would be able to aggregate the data that they are currently sensing in space, put it in a quantum encrypted environment, and with the governance machine and the application engine that we have, we could send that out to the corresponding DoDs or MODs at machine click. And it would happen immediately in a safe environment that nobody would even know it's there. And that's just one of the use cases that we're doing for this pilot customer.
That's fascinating. So mentally, my mental picture I just saw was an asteroid flying towards Earth. Are you talking about that kind of space threat?
It could be, right? That would be cool. That would probably be maybe a NASA pilot that we could do. But this is more around like adversarial threats of interceptions to hack satellites, because the goal is to hack information that's going or coming to that satellite.
Wow. Yeah.
Yeah, that's crazy.
I can only imagine the last decade that you guys have spent thinking about this, on top of the rapid change that we're already living in.
Mm-hmm.
So trying to predict what's going to happen, what's going to be needed 10 years ago today, that sounds like an impossible task almost.
It is, yeah.
Maybe describe some of the challenges you guys have faced over the last 10 years.
Yeah.
And how you've overcome them.
For sure. The biggest thing back then was, and even like to 5 years ago, is how do you, to your point, we know it's a threat, but you can't put a timeline on it, right? Until events start occurring, which is happening now. So it's kind of timely that we started when we did. However, the biggest challenge was, how do you get people up to speed and not say, oh guys, this is great, but like we're talking 20 years away from now, right? So how do you not only sell the vision and the criticality of, if we don't spend the time now, we may never be ready? That was one. Another issue that we sort of ran into was how we started this interview, right? Like when you talk about quantum, how do you say it in a way that everybody, your everyday person who watches maybe an Avengers movie and, sees Ant-Man Quantumania, and they have different perceptions of what quantum is, but like, how do you educate people when you're saying you're building a quantum internet? What does that mean? And like, why should the person you're telling care about it? So education in itself and packaging it down into a way where we can tell a succinct story, bring real life use cases, and educate people on the importance and why they should care about this topic was probably by far our biggest challenge as we were producing this. And now finally we've got to a point where people are listening, they're understanding, and they're coming on board, which is great. And then one of the final challenges that I would say is when you're working on tech like this, there's a huge academic side of this, right? Like there's quantum science where there's a lot of lab work going on. Scientists and academics are doing fascinating things on like the evolution of quantum science. And when we figured out like there's all this innovation that's happening, but we can't commercialize it. And why can't we commercialize it, right? And the simple thing was, it's just, if you want a quantum computer on one side, you probably need a quantum computer on the other side if they're going to talk to one another. And that's just way too expensive. It's just not accessible. People can't make most of it. So the challenges in those 10 years of development was, how do we develop it in a hybrid model where you can use classical systems and quantum machines together in order to move the needle? So that's where we have been focused from. How do we commercialize quantum science in values that are available today? And you lay the groundwork of quantum transformation in your organization. So as things come out of the lab, you have the bedrock and the infrastructure to just plug it in.
Would you say that that change in the way you were approaching it and trying to create that hybrid is how you started to get some traction with people?
Yes, 100%.
So you weren't talking 2 decades from now. It could be
right now.
Yeah,
exactly.
Okay. And what is the feedback? I'm just curious what feedback has been, because my exposure to this is mostly what I read about it. And a lot of it is more fear-based.
Yes.
Because other countries are building this.
Right.
And what are they going to do with it? If they have the power, we don't have the power. What's the feedback been from, particularly when you're talking about the government, but also I'm curious, kind of going back to fintech and financial companies.
Yeah.
It seems like those are probably two distinctly different conversations.
So from the DoD perspective, if you look at their strategic priorities under the Secretary of Defense, they've got like 15 or 20 technology areas listed. I'd say quantum takes about 6 of those. So to your point, you read about it, adversarial nations are making moves in this space, and the DoD cares about that. And it's kind of like, who's going to win the quantum race, if you will. And simply put, we can't afford to lose. Like between the United States and its allies, it's a very critical priority. So the feedback on that side has been very positive. It's more around just ways of working with the DoD in a way that we can apply this technology right now. From the fintech or financial services space, it's more around the issue that I had talked about earlier, where it's like, security and trust is important, but I think we're doing a great job right now. And it's not really on our radar because maybe they've not been attacked yet, or maybe it's not become a problem yet. But then there are other organizations in the fintech space, especially on the cryptocurrency side, where we are seeing so much interest for saying, when can we sign up for a pilot? And this is something that can revolutionize the infrastructure of blockchain, or how cryptocurrency and wallets, digital wallets, can be secured. We want in. So like, how can we try and test that out? So it's been a mix within financial services, I would say, where we've got really great feedback, like where do we sign up, to organizations saying, this is great, this is exciting, but we're not sure we need it right now.
Do you feel like they need to get in soon to take advantage of it?
I mean, the way I would do it, if I was a owner of a fintech company and I know what I know, having had this experience of working with SQS, imagine a world, 5 years from now, and sort of economies are breaking down, stock market is being hacked, financial services, the industry, the transactions could be plummeting. They call it Q day in the quantum world, by the way. It's like doomsday, but Q day is going to come one day.
Why the word letter Q?
Quantum day.
Oh, got you.
And that's when like quantum computers will be breaking encryption left, right, and center, and there will be no warning. It will just happen. So when you think about like crashes or like Q day like that, right? Are you going to be an organization that began your quantum transformation with enough time, where you are a quantum safe world and you are a leader in the way you provide trust to your customers saying, we have quantum safe technologies that will protect your data for any foreseeable threats in the future? Or do you want to wait, maybe take a bet and see how the industry reacts when something like that could happen?
Do you think, I know we're just talking hypotheticals here, but
Sure.
since it's a real thing,
Yeah.
is Q day, can you predict something like that? If you look at, let me ask that question a little differently.
Sure.
So if we're forward looking and we're taking what we know today and we're charting a mental path to a make-believe path to what could be a Q day.
Sure.
What is the likelihood, if we don't do something soon, or that's going to happen and it's going to have an impact?
Yeah, I would say it's definitely going to happen. I can confidently say it's going to happen. Timeline, you just never know, right? They were saying quantum encryption or standard encryption won't be broken until like 2040. Articles are now coming out, it could be as early as 2028, based on what they've seen with other countries and what's happening. I mean, that's dead fast. But, security, encryption, quantum communication is just one value chain we bring. If you think about transactions happening in a compute environment where all these AI models that are being built today and the boom around Gen AI, they use so much compute power that Goldman Sachs released an article that by 2030, the current power consumption demand for AI in data centers is using about 30% right now. By 2030, it will be at 160. So with the amount of power and compute power that AI models are using, we need to think about how we think about data centers and provide that compute power, and quantum technology or quantum solutions like SQS answer that. So if you're thinking about AI is the future with fintech, and you need not only the security aspect that's just foundational, you want to talk about compute power and how you can bring on even more advanced AI models with using less power. That's another value chain to get started.
So does quantum requires less power than AI to power?
So use way more, like quantum computers use way more. But again, it comes down to the way it's architected. So instead of standing up huge data centers, our model is low latency and high frequency, which means we could set up a quantum data center in like those moving storage pod units that you see when people move in. And when you set it up in that way, it uses a lot less power, but you get way more compute power.
I have a neighbor, I won't say his company because people would know it, but we had a conversation the other day and we were talking about power and the power grid and what the next 5 to 10 years looks like. It doesn't seem like we can get there from here unless we go after some of what some people think are like taboo words like nuclear, or otherwise just wind, solar aren't going to get us there. So back to oil, coal, natural gas, or nuclear. Like, when you think about where quantum's going and then where AI is going, that seems like a major factor. And if we don't secure our power grid properly, then none of it works.
Correct. And that's what you just said is like the perfect analogy of like why we started with this project from an internet perspective. Like if you think about how quick tech is advancing, if we don't address the infrastructure issue of our internet technology, there's no way of progressing. It's eventually just going to collapse. And that's why we did what we did. But to your analogy around power and how much it's using, the way we're addressing it from a data center perspective, because people need more compute power, but they want to use less power. And how is that possible? So we architected a data center model that could provide exactly that. But again, it needs to start from the infrastructure level. So these utility companies definitely need to start thinking about like, with the boost in like battery powered cars and robots now one day, it's going to take huge strain on the power grid. So if there's one thing that SQS can do is we said that whatever data center or data pod we would produce, it needs to be 100% sustainable and it needs to use less power. So as companies start doing that within each of their respective areas, I think it'll just be better for our power grids and utilities and as a whole.
If you thinking about the future, in your mind, what is What does the future in the next 5 to 10 years look like when when we think about quantum? Like if we could project ourselves out, we're doing this 5 years from now or 10 years from now.
Yeah.
What's it look like?
I mean, if it goes the way we would like it to go, you could create a world where digital trust, cyber attacks, and words like that are solidified when you think of doing any sort of digital transaction, meaning you could have a world where digital trust exists at the very core infrastructure with quantum technology. It's a huge advancement. And if we apply it the way we see it can be applied and how accessible you can make it, it will literally revolutionize the way we use our mobile phones, the way we communicate in terms of sending data over the web. Things like cyber warfare or hacks would be a thing of the past. I mean, imagine a world where you're running an organization and your CIO doesn't have a single worry about being hacked or a trust issue or a governance issue. Quantum has those capabilities, and it's about if you use it and you install it and you apply it in the right manner, that is a world that I see quantum can have an impact on within the next 5 to 10 years.
With everything that you said, if I were a CIO of a company, I don't think I could argue with you about getting some use case going in my company.
Right. And I mean, the biggest thing that we've seen, right, it's like 100% agree. It's like, does this work? And that's why we took that pilot approach first, right? So like, let's come in, let's have a whiteboarding session, talk about your current architecture, see how this would fit. And that gives us learnings because we're going to be hopefully doing this at large scale one day, where we can start with those pilots and a very simple use case. So to your point, it's been more around now that we're starting to have those conversations, it's becoming a lot easier.
What's next for SQ?
So for SQS, right now, as we launched our company, we were focused on building a team that can go ahead and execute this vision. That's paramount, right? You need a team the right team to go out and do this. So we were up to a world-class team of 17 people now. We've secured pilot customers, some strategic partnerships, and now it's down to timing in terms of fundraising to go ahead and build the product infrastructure that we say we're going to build, the architectures that we've set up, that we've tested. So right now, we are in the midst of our fundraising cycle. But we're not only looking for funds, we are actually looking for partners within the quantum community because we can't build this by ourselves. We have a pretty good idea of what it's going to take, but we need hardware providers, we need software providers. And there are quantum companies that excel in each of those areas. So we're also looking for strategic partnerships to get started on this journey with us. And obviously, you can never say no to pilot customers right now, especially where we're at. So if anybody is quantum curious or say, is this for real? We would love to take you on as a pilot customer.
Yeah, it's exciting stuff.
Yeah.
And what's the Austin community like for quantum?
Austin is probably one of the best places, I would say, just in tech in general, right? And with everything that's happening, I would say it's on the uptick when it comes to quantum. There are some players, some VCs who play in the quantum world, but there are definite more renowned hubs, I'd say, in the United States where quantum is like left, right, and center. Chicago comes to mind with the quantum network that they built. Colorado just state funded a huge initiative called Elevate Quantum, and that's where we're headquartered, is in Colorado Springs, where quantum is usually now the subject that's going to bring jobs, economic development, security, things of that nature. And we're also seeing elements of it pop up in Utah with the huge aerospace industry that Utah drives. Quantum security and quantum communication is a need that's more up and coming.
You mentioned some states I really like. That's great. And some cities that weren't left or right coast.
Correct.
So that's really great to hear. Okay, 2 more things.
Sure.
1, so fascinating what you're doing. For those that might be interested in quantum, like how do they even get involved? Like how do you recommend they get involved in the industry? what advice could you share with them?
So education, honestly, is probably your best bet. And what I mean by education, we can do it in all sorts of micro learnings that are available today. There's LinkedIn articles that talk about quantum that you can read up on. I would say if you're into subscription base, subscribe to the Quantum Insider. It's like literally the Wall Street Journal for quantum, where you can stay up to date on everything that's happening in the world, what's happening from a quantum science perspective, what are the threats that are incoming, things of that nature. And then we just launched a quantum community of interest that is SQS is one of the founding chairs of, mixed with, I want to say 6 or maybe 7 other companies, where we've started a quantum community of interest where we will cover educational topics, but lean more focus on what does this mean for today? Like, it's great to learn, it's great to say what if, but how do we make this real? And providing tangible examples of how it would apply for your day to day. If you're a CIO, if you're a CFO, or if you're a programmer working for a fintech company, like how would this affect your day to day? And communities of interest are a really good way to do that.
And how do they find that communities of interest, and then how do they learn more about SQL?
So with SQS,
SQS, sorry.
No worries. With SQS, you can find me on LinkedIn, Zain Premji, or you can go to our website, which is www.sqs.world. That is probably the best way to get in touch with us. We can link you to the quantum community of interest very easily. Or if you Google Quantum Insider, it will pop up very quickly, and you can subscribe that way as well.
And this has been wonderful. Such an education. Thanks for sharing so much and coming in. Now that I know you're here in Austin, we have mutual friends.
We do, yeah.
Got to have you back on.
Yeah, for sure. Would love to. Thank you so much for having me.
Yeah. Thanks for coming on.
Cheers.
Thank you for listening to this episode. If you've enjoyed what you've heard, don't forget to hit subscribe. And if you'd like to learn more about Customer and the work we're doing building financial and fintech brands and businesses, please visit our website, customer.com. That's CSTMR.com. Or you can find us interacting with clients and sharing insights on LinkedIn. All of these links will be in the show notes.